This video is a solution for the first problem on the exam 2 review problems. Okay, so we're taking a look at this and we're asking for things: the closed loop transfer function, the error signal, the steady state response for 3 times a unit step. All right, so that would look like a reference signal where we are at 0 and then we jump up to 3 over time. And then we're also looking at the steady state response, the error response, when we have a ramp signal that looks like this, or a reference signal that looks like a ramp, and the slope on that ramp is 4. Okay, so let's get started. This block diagram takes a form that we're used to seeing. This would be the role of D. This has the role of G. And this has the role of H. Okay, and so what we know is our closed loop transfer function, y over r. We should just be able to write this down. Hopefully you remember it. If not, it should be on your formula sheet. dg over 1 plus dgh is our transfer function. And so what is d? d is k, s plus 1 over s. G is s plus 2 over s plus 1 squared plus 1 squared, and h is 7 over s plus 7. All right, so I would actually consider that a complete answer because I realize you can just plug everything back into the transfer function. All right, so that's part A. Let's move on to part B. So in part B, one way you can do that is to just notice that this is a type 1 system. How do I know? Well, I look and I see this S in the bottom in the denominator, so that means there's a pole at the origin. And so if I see in the open loop I have a pole at the origin, then I know that's a type 1 system, and type 1 systems track step responses. Even if you scale it by 3, it tracks step responses with 0 error. So, what I would expect you to do on the exam is type 1, which implies the steady state error is 0. Okay? So that moves us to that was actually C. Okay. This moves us to parts B, which you need to address the question in part D. So in part D, we are looking at the error transfer function, and so we should just be able to write that down. The error transfer function is 1 over 1 plus dgh. Okay, so that's our answer from part B, and we've already identified D, G, and H, so we're good. So now when we get to part D, we actually have to plug in and do a little bit of work to find the steady state error. Okay, so we define the steady state error as the limit as s goes to 0. Okay, if the error signal is E of t, then what we're saying for steady state error is that E steady state is equal to the limit as t gets really large of E of t. Okay, and so from the final value theorem, we know that that would be s times E of s times the input signal R of s. Okay, so that's where we are, and we now need to determine what R of s would be. Okay, so what we know is that the reference signal is 4t u of t. That was given in the problem statement. So that means R of s is going to be 4 over s squared. Okay, so plugging into what we have left, we know that E steady state is going to be the limit as s goes to 0 of s times E. All right, so E is 1 over 1 plus dgh times r, and r is 4 over s squared. Okay, so we notice that the s from the final value theorem cancels with one of these s's. All right, so that lets us move down and continue on. So bringing this s down into the denominator, because that's where it is. All right, this would be 4. And then now I'm looking at 1 plus dgh. So at this point, I would go ahead and plug in for d. All right, d is k s plus 1 over s. All right, and I think g is s plus 2 over s plus 1 squared plus 1 squared, and h is 7 over s plus 7. So I plugged in for those quantities, and now I'm asking myself the question, how much algebra do I need to do to get this answer? Okay, so I do think I need to distribute the s across, because what happens is I get a 4 on the top. When I distribute the s across, that would be s plus, and then this s gets canceled. So this would be k s plus 1, s plus 2, 7, and then the rest of this s plus 1 squared plus 1 squared, and s plus 7. Well, at this point, I can plug in 0. I don't have to do any more algebra. When I plug in 0, this term becomes 0, that's a 0, that's a 0. And we just get finite numbers at the end, and it would be 4 over k times 1 times 2 times 7 divided by 2 times 7. All right, you see what I'm doing. I plug in 0, I get the 2 on the bottom here. Plug in the 0, I get the 7. And so these cancel, and my final answer turns out to be 4 over k. All right, so if I increase the gain k, I improve the steady state tracking error to a ramp. Okay, so I'm going to do a different video that talks about the MATLAB interpretation of this problem, and so watch that one next, and you can understand, the things I want you to know about MATLAB on the exam.